Hello everyone, welcome to this video. In this video, we will be covering the MCP server basics and why do we need the MCP servers, and we will also create a practical application using the MCP server. Before talking about the MCP server, let's discuss about a scenario. Imagine you ask an AI agent, plan a 3-day trip to Goa for me next weekend, book a flight, find a good hotel under $5,000 per night, and share the itinerary on email. Now this sounds like the perfect AI assistant, but let's see what actually happens. The agent is actually very capable here. It understands the destination, it can identify the dates and plan the duration of it. It can also decide the tasks, such as finding flights, finding hotels, create itinerary, send email. So the agent has no problem figuring out what needs to be done. However, the agent will break at the step where it has to find out which airline API to use or which aggregator to use, what sort of payment to use, how to authenticate, how to connect to Gmail, etc. The agent doesn't have a standard way to interact with all these different systems. At this step, developers end up integrating flight APIs, hotel APIs, payment systems, email services, and writing custom logic for each. Here, every integration is different as every system speaks a different language. This is manual and messy without a standard. The real issue here is that agents don't fail because they're not smart. They fail because they don't have a reliable way to take actions. In the above example, the airline API is different than that of the hotel API, which is then different than the email API. There is no standard input or output. Let's take another example. Suppose we want Claude to connect to Jira, create some tasks, and then communicate those tasks over Slack. An AI agent can understand what needs to be done, but without a standardized interface, each tool would need to be integrated separately: Jira, Slack, email, and so on. This quickly becomes messy and error-prone. This is where the MCP comes in. MCP solves this by providing a consistent. Let's now take a look at the MCP documentation at modelcontextprotocol.io. The documentation explains MCP very nicely with an analogy. Think of MCP like a USB-C port for AI applications. Just as USB-C provides a standardized way to connect electronic devices, MCP provides a standardized way for AI applications to connect to external systems. MCP is an open protocol supported across a wide range of clients and servers. AI assistants like Claude and ChatGPT and development tools like Visual Studio Code, Cursor, and many others all support MCP, which makes it easy to build an integration once and use it everywhere. If you're interested in going deeper into MCP, the official documentation at modelcontextprotocol.io is an excellent resource. It not only explains the architecture and design principles of MCP, but also includes practical examples showing how to build programs that use MCP. For instance, the documentation shows how to build a server that exposes tools for AI agents to use, connect multiple AI clients to the same MCP server reliably, define tools, prompts, and resources in a standardized way so that AI systems can invoke them predictably, use different transport layers such as SDDIO for local tools or HTTP for remote tools, making integrations flexible. These examples are really helpful if you want to experiment with MCP in real applications, like connecting Slack, Google Calendar, or other tools to AI agents in a unified manner. I highly recommend taking some time to go through the documentation. It shows step-by-step examples of integrations and demonstrates best practices for building robust MCP servers and clients. By studying these examples, you can get a clearer picture of how MCP simplifies AI interactions and makes tool integration seamless. Now that we understand what MCP is and why it's needed, let's move from theory to practice. We'll build a simple example where an AI agent sends a message to Slack using an MCP server. In a demo, we'll explore how AI agents can interact with tools in a standardized way using an MCP server. Imagine you ask an AI agent, "Send a friendly update message to my team in Slack about the new MCP features." At first glance, it seems simple, but let's break down what actually happens behind the scenes. The AI would need to know Slack API endpoints, webhook URLs, JSON request format, authentication method. Each tool is different, and AI has no built-in standard for all of these. This is why agents often fail in real-world tasks, not because they're not smart, but because they lack a reliable, standardized way to act on tools. This is where MCP comes in. MCP standardizes how AI interacts with tools. The AI doesn't need to know the API details of each tool. It just sends a standardized request to the MCP server, and MCP handles the rest. Let's start with server.py, which acts as our MCP server. This is the component responsible for exposing tools in a standardized way. It exposes tools like Slack through a consistent interface. The AI sends a request in a standard format. MCP server receives it and performs the actual action, like sending a Slack message. This is what we mean by standardization via MCP. Let's now run our MCP server. On the screen, you can see the command we're using. We're starting the server using Unicorn. Once the server is up and running, we can open the browser and go to http://127.0.0.1:8000/docs. This brings us to an interactive API documentation page, where we can see the available endpoint to send a Slack message. If we open this endpoint, you'll notice that it accepts a very simple JSON input, just a message field. Let's quickly understand how our server.py file is set up. We're using FastAPI to create a simple MCP server. This allows us to expose functionality as an API that the AI agent can call. Then we create an endpoint called /send_Slack_message. This is the key part. It acts as the interface between the AI agent and Slack. Inside this function, we first generate a timestamp and format the message in a readable way. After that, we send this message to Slack using a webhook URL. So essentially, this is where the actual integration with Slack happens. Finally, we return a structure response. This is important because MCP expects responses in a consistent format that the AI agent can understand. So overall, this server is acting like a bridge. It hides all the Slack-specific complexity and exposes a clean, simple interface for the AI to use. So instead of worrying about Slack APIs, authentication, or request formats, we now have a clean and simple interface to work with. Inside the function send Slack message, we take that message and send it to Slack via a webhook URL. So all the Slack-specific logic, which is formatting, authentication, and API call, is handled here. This is what the MCP standardizes. The AI agent does not need to know how Slack works. It just sends a message to the standard interface, and the MCP server takes care of the rest. In our case, client.py is acting as the AI agent. You can think of server.py as the translator between the AI and external tools. Now, let's look at client.py. We generate a message using Alma, a local AI model. The message is sent to the MCP server endpoint. The MCP server formats it and posts it to Slack via the webhook. Notice how the AI agent or client.py in our case doesn't know the Slack details. It only cares about the content of the message. This is exactly how AI agents interact with multiple tools in a reliable, predictable way using MCP. Let's see in action. I'll run client.py. You can see Alma generates a friendly message dynamically. The MCP server receives it and sends it to Slack. Here in Slack, we see the message appear instantly. This shows AI agent, MCP, and Slack in a fully working flow. This can be extended to any other tool, Jira, email, databases, with zero changes to the AI client. That's the power of standardization via MCP. In the previous demo, we had included the MCP in the code. Let us now see some of the major tools using the MCP server. For example, Claude also provides the capability to connect to different apps like Slack, Google Calendar, and many more. Imagine asking Claude, send a friendly update to my team on Slack about the MCP demo. Notice that Claude understands the request and even drafts the message, but it cannot actually send it to Slack. That's because right now it has no direct way to interact with external tools. So the limitation is not intelligence, it's lack of actionability. Claude is smart, but each tool has a different API. Slack requires webhooks, Jira has REST endpoints, and emails require SMTP. If Claude had to handle all of this on its own, it would be messy and error-prone. However, once we configure it via MCP, then it will be able to send the message as well. That is it for this video. Thank you.